Good day, everyone. This video is concerned on rationalizing denominators. We are still on lesson number 3, concerned on multiplication and division of radical expressions. Rationalizing denominators came into place because there are some results when we divide radical expressions where the denominators still contain radical expressions. Do not get me wrong. The values are still correct. The values are still acceptable, but we need to manipulate the result or the given so in such a way that there would be no radical expressions found in the denominator. In the previous video, we have started rationalizing denominators, but the denominators given in the previous video are all in monomial term, or we only have one or singular radical expression found in the denominators. This video will be concerned on denominators of a binomial expression. I mean, the denominators are already in a binomial expression. In short, there are two terms found in the denominator separated by either addition or subtraction. Let me show you some examples. Here, we have 4 examples to solve for this video. Take a look at the given for numbers 1, 2, 3, and 4. The denominators now are in the form of binomial expression. We have two different terms. In number 1, you have a rational number 4 to be added with a radical expression. Number 2, you have a radical expression to be subtracted by a rational number. In numbers 3 and 4, both terms in the denominator are now in radical expressions. So we are going to rationalize them. Right? Last time when we rationalize denominators, we also focused on a singular term or monomial terms. We just look for a factor that that could be multiplied to the denominator and simplify it further. Here we are still going to use the same, but there are important concepts that we need to apply first before we are going to rationalize them. One of which is the topic or the concept of difference of two squares. Sorry, difference of two squares. This concept is already presented to you in the previous grade level. When you say difference of two squares, it is in the form of generally it's in the form of x squared minus y squared. Hence the name difference of two squares. Okay, if we have difference of two squares, we can actually factor them out. Okay, the factor is we have two binomial factors, which are x minus y and x plus y. If you're going to multiply this again, you will still get the difference of two squares form in the form of x squared minus y squared. So again, the factor of this form, x squared minus y squared, is we have the first binomial, x minus y, and the second binomial, x plus y. Or if you will choose to have here plus, you will also use here minus here. Okay, so as long as the signs are opposite for both of them. Okay, why we are presenting this concern? Because we are going to apply here the concept of difference of two squares when we are going to rationalize denominators. Okay, so let's take for instance number 1. You have 2 over 4 plus square root of 3. If we are going to apply what we have learned in the previous video to simply multiply this by a value equal to 1, which is square root of 3, okay? So value equal to 1, so this should also be square root of 3. If you will stick with that, when you multiply the denominator, it will result to 4 square root of 3 plus square root of 9, which is equal to 4 square root of 3 plus 3. You may say, I have rationalized, sir, the radical expression here. But when you look at the other term, it now contains another radical expression here. So what do you say again? I will multiply this again, sir, by another square root of 3. If we're going to do that, you'll just be repeating the process and you will still get a radical expression in the denominator. Therefore, This is not the correct factor to multiply to be multiplied or factor to be multiplied to remove the radical expression found in the denominator. We are going to use here the concept of the difference of two squares. In short, since the denominators are now in binomial form, we are going to multiply here an expression equal to 1, which is actually also in a binomial form. Okay, in a binomial form. Okay, and what are we going to multiply here? We are going to multiply here as the same concept from this difference of two squares idea. Now, these two binomials here are also known to be conjugates. Conjugates. When you say conjugates, this means that we have the same first term, you have same first term, same last term, but opposite in sign. Okay? Conjugates are considered to be two binomial expressions with the same first terms, same last terms, what but opposite with opposite operations. And by using the conjugates, you will get the concept of the difference of two squares. Hence, what we're going to multiply here is the conjugate of this. So the conjugate of this denominator is same term, same first term, 4, same last term, square root of 3. And then opposite sign. Since it's plus, we will have here minus. Okay? We will have here minus. So this is now the conjugate of the denominator. And since we are multiplying here a value equal to 1, so that we are not changing the given, we will have here 4 minus square root of 3 still. Okay, so this is what we are going to multiply to the given to rationalize it. Let us see if we can really rationalize the given. This would become 2 times 4 minus square root of 3. You have a monomial to be multiplied to binomial. And you have 4 plus square root of 3 times 4 minus square root of 3. The numerator simply needs the distributive property. The denominator needs the concept of the most familiar concept when multiplying two binomials, the FOIL method. Okay. This is the most common or the most popular. Okay. Then we multiply the numerator. 2 times 4, you have 8. 2 times square root of 3, so you have minus 2 square root of 3. And then we use the FOIL method to multiply the denominator. So you have 4 times 4 for the first terms. You have first terms, 4 times 4. So you have 16. And then the outer terms, 4 times negative square root of 3. You will have here minus 4 square root of 3. Inner terms, these two. So you will have plus 4 square root of 3. And finally, for the last term, positive square root of 3 times negative square root of 3, you have minus square root of 3 times 3, 9. Using the FOIL method, we know that these two will be simplified because that's negative 4 and plus 4. That becomes 0. 0 what? 0 square root of 3, which is still ultimately equal to 0. And then the numerator, you will have the numerator will still become 8 minus 2 square root of 3 because it cannot be simplified further over 16 minus the square root of 9, which is 3. And then your final answer is 8 minus 2 square root of 3 all over 13. Do not worry with the radical expressions found in the numerator because our only concern is to rationalize the denominator. Okay? Let me go back to the term FOIL method. You may use this as part of your checking, but of course, you could just simply skip this process and just after this, you can just simply from the second step proceed to the last step. because we all know that they are conjugates and they should return to a difference of two squares. In short, without using the FOIL method, okay, this is the FOIL method is what we used here. This is the FOIL method, right? But even without using the FOIL method, you can simply use the difference of two squares. We have conjugates. So this would result to the numerator 8 minus 2 square root of 3 all over difference of two squares, conjugate siya, 4 squared, 16, minus square root of 9. We have difference of two squares. And then ultimately, it will return to this item here. So either way, they will have the same result. The FOIL method will take a longer period of time because you are going to multiply four different pairs of terms. But if you're going to use the difference of two squares, just by examining the conjugates, you can simply say square the first term, square the last term, and use the operation of subtraction. Let's use that for number two. Number two, you have square root of 2 over square root of 5 minus 1. So to rationalize this, we are going to use the conjugate of the denominator. Square root of 5 plus 1. Same first term, same last term, different operation. And then to make sure that this is equal to 1, we will have the same value with the denominator here. Okay? So earlier, it was the given was plus. Here, the given is subtraction minus. So conjugate is now plus. So let's try to multiply. So you have square root of 2 times square root of 5 plus 1. And then simply use the difference of two squares for the denominator. Square root of 5 times square root of 5 is square root of 25. And then 1 times 1, 1. And use difference. Difference of two squares. So this would become, the numerator becomes square root of 10. That's 2 times 5 plus square root of 2 all over square root of 25 if 5 is 5 minus 1. We cannot add square root of 10 and square root of 2 because, again, when we add radical expressions, they must have the same index and radicand. And of course, we cannot simplify 10 because 10, except for 1, has no more factors, which is a perfect square. So the final answer is square root of 10 plus square root of 2 all over 4. So we have rationalized item number 2 already. Let's proceed to number 3. Number 3 may take a longer period of time because in the numerator, we have here a binomial expression. Plus 1 over cube root of 3 minus cube root of 2. Either way, anyway, we're just simply going to multiply this with a conjugate of the numerator, not the denominator. So square root of 3, you have here square root of 2, and you will use plus. And same here, 3 plus square root of 2. So the numerator will involve FOIL method because you have square root of 3 plus square root of 1, plus 1 times square root of 3 plus square root of 2. All over, we can just simply use the difference of two squares for the denominator because we have conjugates. So we have square root of 9 and then square root of 4 and then we have minus. So using the FOIL method in the numerator, FOIL method, so you have square root of 9 for the first term. Outer, you have plus square root of 6. Next, you have the inner plus square root of 3. And the outer and the last terms, we have plus square root of 2. Okay, square root of 2. All over, the square root of 9 is 3 minus square root of 4, which is 2. And then we can simplify now the numerator. The numerator now will have square root of 9, which is 3, plus square root of 6, plus square root of 3, plus square root of 2, all over 3 minus 2, which is 1. Of course, we can actually have the final answer as simply 3 plus square root of 6 plus square root of 3 plus square root of 2. No more all over 1. So this is the value for number 3 because we cannot combine any of this anymore. We have a rational number and three irrational numbers with different radicals. Last item. Last item is 7. 7 square root of 2 all over 7 square root of 2 minus 2 square root of 7. So let's multiply this with the conjugate of the denominator, which is 7 square root of 2 plus 2 square root of 7. Okay. Make sure that they are equal to simply equal to 1. They are equal to 1. Okay. So let's multiply them. The numerator becomes 7 square root of 2 to be multiplied by 7 square root of 2 plus 2 square root of 7 all over. Use the concept of the squaring of the first and second terms using the concept of difference of two squares because we have conjugates here. So that's 7 times 7. You're still going to multiply the numerical coefficients. 49 times square root of 4 and 2 times 2, that's 4 square root of 49. And then you have minus here. And then you are going to multiply this. So 7 times 7, you have 49 square root of 4 plus 14 for the second term. Right? 14 square root of 14 all over. You have here 49. Square root of 4 is 2 minus 4. Square root of 49 is 7. Let me continue it here. So the numerator becomes 49 times square root of 4, which is 2, plus 14 square root of 14 still, because 14 cannot be simplified anymore. All over 49 times 2 is 98 minus 4 times 7 is 28. Okay, 28. So you have here 49 times 2. Okay, or wait for a while. We may not multiply them. Okay, why? Because this is the next process here. Okay, so we have 14 square root of 14. The denominator becomes 70. Why did I not multiply this first? Because we can still simplify this further by factoring out 2. So you have 49 plus, you factor out 2 from 14, you have 7 square root of 14. And the denominator has 2 times 35 for your 70. Okay. Of course, you can still multiply this earlier, but still you're going to factor out because we will do this here. So the final answer for number 4 is 49 plus 7 square root of 14 all over 35. Again, it's very long, but no need to rush. Do it step by step. Please consider all necessary processes involving in simplifying radicals, multiplying radicals, division of radicals, addition of radicals, operations of radicals, all everything, and the loss of radicals. So this is our final answer for number 4. Okay, I will have only 4 items here because I believe the 4 items here could already capture how to simplify radical expressions in the denominator or rationalize binomial denominators involving square roots. Still on square roots. Okay, so use this video as you will try to simplify more radical expressions and as you review for in preparation for probably an assessment or more activities soon. Okay, so thank you very much for watching and for viewing this. Hopefully, you have learned and you will continue to work on your mathematical processes. Goodbye.